All right, guys, so we are starting Chapter 3, Section 3. Pretty much the rest of this chapter involves handling exponents and how exponents are affected when you do operations on an expression. We are going to start with a quick little vocabulary review. The 2 in this problem is called the coefficient. The x in this problem is called the base. It's a variable, I know. A variable could be a base, or a number could be a base. The base is the thing under the exponent. And of course, the 3 is called the exponent, right? Over here I have another example of 2 to the 5th power. Of course, the exponent is the 5 and the base is the 2. And here I wanted to show you 3 different ways that this expression could be written. One way it could be written is in expanded form. Expanded form is when you use the exponent and show what the exponent means. It means to write it out as a multiplication problem. 2 times itself 5 times. That would be expanded form when we show it as a product. Exponential notation would be the way it's already written. That would be with an exponent. That's why it's called exponential notation. And decimal notation would be where you actually calculate the result. 2 to the 5th power, 2 times 2 times 2 times 2 times 2, and that is 32. Sometimes we will want to answer questions in expanded form. You'll have a few questions on your homework like that. Sometimes in exponential notation, and sometimes we'll want you to get the answer in what we call decimal notation. So as I said before, most of the rest of Chapter 3 involves this right here. When you do operations on terms that have exponents, how are the exponents affected? So I have a couple of questions to try here. The first one is 3x squared y times 5x to the 3rd y. And the answer to that would be 15 x to the 5th y squared. I have another one that just involves numbers. 2 to the 3rd times 2 to the 5th. What do you think that is? Could be 2 to the 15th. Could be 4 to the 15th. But it's actually neither of those. This actually equals 2 to the 8th power. Let's see why with our first rule of exponents. 2 to the 2nd times 2 to the 3rd. What does 2 to the 2nd times 2 to the 3rd actually equal? Well, we know that 2 to the 2nd power is really equal to 2 times 2. And then you've got this big multiplication sign. And we know that 2 to the 3rd power is really equal to 2 times 2 times 2. So there's your 2 to the 2nd. And there's your 2 to the 3rd. And when you multiply all that together, what you actually get is 2 to the 5th. There are 5 2's being multiplied together. That would be in exponential notation. And then if you multiplied that out, it would equal 32. The thing for you to see is this. When you multiply 2 to the 2nd, which is 2 times 2, times 2 to the 3rd, which is 2 times 2 times 2, what you're actually doing is multiplying 5 2's together. And that leads us to our rule. This is called the product of powers rule. Product of powers because we're multiplying together 2 things that have a power on them. And the rule says this. When you multiply two expressions with the same base, you add their exponents. That is why 2 to the second times 2 to the third equals 2 to the fifth. We're going to look at 4 examples here, and we're going to go clockwise with these examples. The first one, A, x to the 7th times x to the 5th. Well, using our rule that we just learned, that would be x to the 7 plus 5, which is x to the 12th power. X to the 7th times x to the 5th is really just 12 x's being multiplied together. How about example B? 3 to the 2nd times 3 to the 5th. Again, because these have the same base, and you can only do it because they have the same base, you can add the exponents together. This would equal 3 to the 2 plus 5, or 3 to the 7th power. And we're just going to leave it in exponential notation like that. I'm going to do letter D next, and I want to point something out. In letter D, unlike letter B, the bases are not the same. And because the bases are not the same, we cannot use the exponent rule where you add the exponents together. That only works if the bases are the same. In this case, we're going to have to go ahead and follow our PEMDAS rules, right? Do parentheses, well, there are no parentheses, but there are exponents. So the first thing I would do is take care of this exponent. 2 to the 3rd power is 8. And 5 to the 2nd power is 25. And then I can go ahead and multiply these together. 8 times 25 is 200. Notice, when the bases were not the same, I could not use the exponent rule. I needed to go ahead and follow the order of operations. And then last up, letter C. I am multiplying these things together. Well, let me show you something here. If you break these apart and you write this as 5 times x to the 5th times, and you write the 4x to the 3rd as 4 times x to the 3rd, what you really have here is 4 things multiplied together. And when you are just multiplying things together, you are allowed to rearrange the order they're being multiplied in. This would go ahead and equal 5 times 4 times x to the 5th times x to the 3rd. And that allows me to go ahead and multiply the numbers together, 5 times 4, and multiply the variables together. The x to the 5th and the x to the 3rd do have the same base. Therefore, I can add their exponents and get x to the 8th. 20x to the 8th is what I get there. And I just want to go ahead and show you one more time how that works. Generally, when you multiply terms together, you multiply the coefficients and you add the exponents on any common variables. Let me do one more of those just to make sure we know what we're doing. So here I have an example, 3x squared y times 5x to the 4th y to the 3rd. Let me go ahead and rearrange that the way I just did the last one. Let me write 3 times, and I'm going to put the 5 next. Then I'm going to put the x's times x squared times x to the 4th. And then I'm going to put the y's times y to the 3rd. Those are all the things that are actually being multiplied together. See how the coefficients actually get multiplied together, and we end up with 3 times 5 is 15. The x's that have the same base, we can go ahead and add their exponents. That would be times x to the 6th. And the y's also have the same base. we can go ahead and add those together. Now don't forget, the y that does not have an exponent really has an exponent of 1. We just don't write the 1. So that would be y to the 4th. So we multiply the coefficients, but we add the exponents on the common variables. All right, let's see if you really get this. Let's try this one problem. It says, with your partner, determine 3 more ways to write a product using 2 as the base that would give you the same answer as the problems below. All right, I know you don't have a partner because you're watching this online. However, you can try it on your own. Here's a problem. I claim that 2 to the 5th times 2 to the 4th would equal 2 to the 9th. Can you write 3 more problems that use 2 as the base and give you the same result, 2 to the 9th power? Well, let me get you started. You can pause it if you want to try it on your own. It would be maybe 2 to the 6th times 2 to the 3rd. That would be 2 to the 9th. How about 2 times 2 to the 8th? That would be 2 to the 9th. And last up, how about 2 to the 7th times 2 to the 2nd? Of course, there are many options here. Those are the 3 I came up with. Maybe you came up with something different. Let's look at our next rule. Our next rule are for problems like this. Now, the first thing I might do with this problem, x squared to the 3rd power, is I might try to write it out in expanded form. Right? This exponent of 3 is telling me take the x squared and multiply it times itself 3 times. So that might look like that. And now I can use the rule that I just learned. When I am multiplying things together that have the same base, I add their exponents. So this would equal x to the 2 plus 2 plus 2, or x to the 6th power. Well, we'd like a shorter way to get that answer. Instead of taking 2 steps to get it, we have an exponent rule that will get you the answer in 1 step. And it is called the power to a power rule. It's when you have an exponent raised to another exponent. And here's what the rule says. When you have an exponent, that was kind of silly, raised to another exponent, you multiply the exponents together. So the example we just did, I could do in 1 step by saying x to the 2nd power to the 3rd power would really be x to the 2 times 3. I am multiplying the exponents together. And that gives me x to the 6th power. Here I can do it with just numbers. 3 to the 2nd power to the 5th power. Using the rule I've just learned, the power to a power, when you have an exponent raised to another exponent, you simply multiply them together, and in this case, get 3 to the 10th power. Now, a lot of times when the exponent is large, like 10, we will go ahead and leave it in exponential form. Or we could get our calculator out and figure out what 3 times 3 times 3 times to the 10th power is, right? Last up, I have a variable, n to the 4th to the 11th power. That would be n to the 4 times 11, because I have a power raised to another power. And that, of course, gives me n to the 44th power. All right? We've got one more rule on this homework. It goes along with those 2 rules, so it's not too difficult. And it's called the power of a product. It says when you have an exponent on a product, right? Remember, a product is simply stuff multiplied together. When you have stuff multiplied together and you have an exponent on the entire product, then the exponent gets applied to each individual thing in the product, which is in the parentheses. I have a number of examples here, and I will point these two things out as we use them. So in example A, I have a product, 2 times x to the 5th times y to the 2nd, and it is all to the 4th power. So this rule says that you can take that 4 and you can apply it to each term in the product. That would be 2 to the 4th power, x to the 5th to the 4th power, and y squared to the 4th power. Normally I would not write that step out. I do that for demonstration purposes only, really. I'd probably do it in my head. But you can see how each term in the product got raised to the 4th power. And now I'd go ahead and get the results. 2 to the 4th power is 2 times 2, 4 times 2, 8 times 2, 16. Here I have a power raised to a power, so I multiply them together and get x to the 20th. And also here I have a power raised to a power, so I would multiply those together and get y to the 8th. And my final result is 16 x to the 20th y to the 8th. I think this second one is an interesting example. Should I follow PEMDAS and do parentheses first, or should I use my exponent rule and apply the exponent to each thing in the product? You know, the two things being multiplied together. Well, if this exponent rule is a good rule, it will give you the same answer that PEMDAS would. Watch. I could do PEMDAS first, multiply 2 times 5 and put it to the 2nd power. And of course, that would give me 10 to the 2nd power, or 100. Or I could apply the 2 to each thing and go 2 to the 2nd power times 5 to the 2nd power. Now, those do not have the same base, so I'm going to have to go ahead and do the exponents first. 2 to the 2nd power gives me 4, and 5 to the 2nd power gives me 25. And 4 times 25 is, of course, 100. And I got the same answer either way. That tells me that this rule is a good rule. It gives me the same answer as PEMDAS did. So in our last example, one more time, I am taking this 2 and I am applying it to each term in the product. I would have negative 3 to the 2nd, w to the 2nd, x to the 4th to the 2nd, y to the 3rd to the 2nd. And here we go. Let's evaluate. Negative 3 to the 2nd, positive 9. W to the 2nd is, of course, w to the 2nd. Again, here I have a power to a power, so I'm going to multiply those and get x to the 8th. And here I have a power to a power, so I'm going to multiply those and get y to the 6th. And I have now applied the exponent to each thing in parentheses. All right, I have one more note here for you, and that is when there's more than one operation to do, don't forget about our good friend, Mr. PEMDAS. Right? So in this first example, I have a power to a power here, and I have a power here that needs applied to parentheses. Applying exponents should be the first thing I do here. On the left side here, I'm going to have 5, and the x to the 3rd to the 4th would be x to the 12th, right? Because I have a power to a power, and so I multiply them together. The second one, I have 3 to the 2nd power, and I have x to the 6th to the 2nd power. So 3 to the second power gives me 9, and x to the 6th to the second power gives me x to the 12th. Now, I have these two terms that possibly I can add together. I can only add them together, of course, if they are like terms, which they are. And don't forget, when you add like terms together, you do not change the variable in the exponent. You just add the coefficients. 5 plus 9 gives you 14, x to the 12th. Let's try one more time and we'll be done. Here I need to apply the exponent first. That gives me 4 x to the 6th power plus, here I need to multiply these together. The 5 times the 3 gives me 15. And the x's, again I'm multiplying here. When you multiply, you add the exponents. That gives me x to the 5th. Now I have these two terms that I can add together, but in this case I can't, right? These are not like terms. They don't have the same exponent. This is your final result because these are not like terms. Hope that helps. Good luck on the assignment.